Ladies and gentlemen, welcome to Auth Part 3. Let's see if I still remember how to teach. All right, so by the end of this lesson, I hope that each and every one of you will be able to verify tokens in Rails and protect resources with tokens. So, as promised, first thing that I want you to do is go through everything in part 1 and everything in part 2. We got to dust ourselves off a little bit and remember how to program and see if we can do all the steps for creating users, do all the steps for authenticating a user, and then and only then we talk about once somebody sends us one of these tokens, what the fuck do we do with it? Cool. Questions before we get started? Cool. So I'm going to put 10 minutes on the clock. Let's start there and try to get through these first two sections on your own. 10 minutes on the clock, go.
Kyle, I think you're muted.
That is exactly what's happening. And even as I muted, I'm like, oh man, I'm going to forget to fucking do this. All right, so give me a fist of 5. Where a fist is, I have no idea what we were supposed to be doing just now. And a 5 is, I got a token coming back, baby. Very nice, very nice. Alan, how you doing?
I'm running into a really weird error with my user creation. I'm not sure exactly what it is. It's a syntax error. So,
all right, we'll walk through it together. Javarie, Kevin, Alex, Jordan, you can throw it in chat if you want. Thank you, Javarie. Very nice, very nice. All right, so let's walk through this together. All right, I have not written a line of code since we got out of school in December. So let's see if I still remember how. All right, so I'm going to call this Auth Part 3 Jam. All right, so I am going to Rails new -- API. And I'll call it backend or something like that. All right, I'm going to CD into that. And then, hang on, my kitchen timer is going off and I don't know who set it and the oven is on. Give me just a sec. No clue what that was. All right, so I'm going through my steps. Install Bcrypt. Well, I know how to do that. I'm going to go over to a gem file. Uncomment. Bundle install. Pew pew. Create a route to create a user. Well, first place to start would probably be the router. So if I make a post to users, that should go to the users controllers create action. Cool. Create a controller to create a user. Well, I can Rails G controller users. Go over to that controller, make a create method. Same way we've been doing since mod 2. This will be user.create username params username password render JSON, and we'll send it on back. Give it a created status as well. By the way, the first time I saw this syntax, I like puppy dog faced pretty hard. This is the symbol status being assigned to the symbol created. All right, so I've got that going. Now I need to create a model with a secure password. So I Rails G model user. Open up that file. Tell it that this has a secure password. I'm going to go over to that migration and make a username string and a password digest. string. And just to reiterate, these aren't like the only things that you can put on a user model. We can put their age, we can put their real name, we can put whether or not they're a manager, whatever. Any other thing that's a part of our users, we can also put those things on here. But we need some way that we can look them up, and we need some place that we can store the hashed password. All right, so this all looks pretty good to me. I'm going to Rails DB migrate while I open up Postman. And I'm going to fire up that server. All right, localhost 3000 users. I make a post request, send over a username and a password. And I get back my logged in user, or my user that I can log in with. So before I move on, questions about anything I just did? We should be pretty solid on that process at this point. Conceptual question, I want you to think, what is a hash? We've talked about that quite a bit too. But if I were to ask you, as I'm about to in a second, what is a hash? I want you to take a second and think of what your answer would be. All right, I'm going to call on Javarie. Give it a shot. What is a hash?
Dang. I was looking it up a little bit because I still don't have a really good definition, honestly. I just know that it's just nested data. And I think it has to do with
not the data structure. I mean, like as in hashing the password. Why do we hash the password? What is happening there? That kind of thing. It's okay if you don't have the whole answer. Give me like the pieces that you know.
Oh, okay, then like I know that we just want to nest it and change it so that when we don't actually want the computer to know the actual password and like what they typed. We want the computer to recognize the, I don't know what to call it, but what we get back from that, the hash or whatever, and be able to recognize that instead of using the actual password.
Excellent. So we got some excellent pieces of the puzzle in there. Chris Henderson, give me some more pieces.
So hashing is basically that encoded password, but irreversible.
Yes.
It cannot be, well, basically you can't reverse it back to whatever it was. It'd be kind of impossible.
Yes, that's another key part of this. So Javarie added that we don't want to store the actual password. We want to store something that like we can verify that somebody gave us the right password, but we didn't actually store it. Mm-hmm. Chris gave us that the way that works is it only goes one direction, can't go the other way. One nitpick, be careful about using the word encoding for that, because encoding is a different thing. Encoding goes either way. Encryption goes one way, but it's more difficult to go one way than it is the other. So if I send you an encrypted message, it's not as easy to crack as something that's just encoded is, because like if it's encoded, it's like pig Latin. We just swap the stuff around and figure out what it is. When something's encrypted, it's like that, except it's easy to encrypt something and very difficult to decrypt something. That's what makes it secure. And then hashing is our third piece of this, where it only goes one direction and it's impossible for it to go the other way.
Also, with hashing, I'm sorry if you're going to call on somebody else.
No, go ahead. I want to hear it.
With hashing, we also add salt to it as well. That also helps with the uniqueness of it, like what we have stored in our database. So
definitely. All right, so my next question, all of these things are true and they're awesome. So my next question is going to be like, how does that work? How could it possibly only go one direction? So think to yourself, for a
Winnie.
second. Think to yourself. Cass, how is it possible that it only goes one direction?
This is a guess, but it would like replace it in the database.
Expand on that idea.
The original one wouldn't be stored anymore.
So yes, so we're not storing the actual thing, but what makes it so that if my password is Kyle and the hash, so that's my password, that's the thing that actually got stored in the database. Okay, so if I had this hash, how come I can't just turn that back into Kyle? How does that even work if I can't reverse it?
I'm not sure.
Okay, so let's help Cass out. Gerald, give me an idea of why that only goes one direction.
I'm not quite sure either.
All right. Do you have any guesses?
Yeah, let me see. I'm trying to think back to our previous two lessons. They were a while ago now. Yeah, but I'm struggling. I don't have a good answer for it. I'm sorry.
Okay. No, that's fine. This is exactly why we're talking about this. Alan, can you help out Cass and Gerald?
I think it's got to do with the fact that the hashing thing is what it's doing is it's taking all this type of information, including what you inputted, and mixing it all up together. Yeah, and so basically the way it does that, the probability that you could repeat that intentionally is astronomical.
Correct. So let's take a look at this one more time. So in Kyle's Garbo hashing algorithm, we take some characters like cab, and then we just figure out what place they are in the alphabet, and then we sum those together until we get a single number. And so if we got a bigger number than that, we would just keep summing it together until we got one number. And so the reason that we can't reverse this is how could you? Cab can be 6. The letter A 6 times would also be 6. Letter B 3 times would be 6. There's a near infinite number of ways that we could generate this exact same hash. But to what Alan's point was, the likelihood that you can intentionally do that is just very low. So I'm going to ask again, how would you explain why hashes only go that one direction? But first, I'm going to give you a chance to ask any clarifying questions.
I can try to explain it. Or was it me or Jerry?
But both of you. Cass, how come hashes only go one way?
It's kind of explaining it, but obviously if it's wrong, it's also kind of a question.
Yeah.
I think it's like, so it takes the password that you put in and it uses that password to jumble it all together and make this new thing. And the odds of that happening in the way that it happens with hashing are, it's just not going to happen that way again.
An outstanding answer. Gerald, exact same question. How come hashing only works one way?
It seems the simplest way to put it is to say something along the lines of the hashing a logarithm makes it practically impossible to determine what the inputs were for the given output, which is the hash.
Yes, that's an excellent answer. Now, it's impossible to guess what the inputs were, but if we have the inputs, easy as hell. It's what we call deterministic. If you hash the same string, you'll always get the exact same result. So that's how we can verify passwords. Anybody have questions about any of this stuff in part 1? Cool. So let's keep on trudging forward. So for our next thing, for our next trick, we want to do these things. So we need a login route. Can do that. A post to login should go to an authentication controller's login action. And this one's kind of interesting because we wouldn't be able to just create resource with this. This is one of the reasons it's good to know both syntaxes, because authentication isn't a resource. It's like an action that we're taking. So we don't have a create method or anything like that. We're using this login action. It's just something we made up. We can call it fart if we want to. So that means I need an authentication controller. So I'm going to create a login controller in action. Rails G controller authentication. I'm going to log in. And then, so inside of this, these are the things I want to do. Look up a user, authenticate them, create a token. So they're sending me their username, so I can use that to look up a user. Find by username, params, username. Excellent. So if there's no user, that means that there was nothing in the database that has that username, whatever they gave me. And that's a hint that bad username. So you didn't log in. Neat. I can render JSON message that says something like bad username. Give us a status of unauthorized. Cool. That's it. I looked up the user. Now I need to figure out whether or not the password they gave me is right. So I could say something like, if not, at user.authenticate. That was one of our magic methods that we got with has secure password. If that didn't work, you can say bad password. Cool. So if they got to here, they are authenticated. They are who they say they are. Now, actually, let's test that. That was an awful lot of things and an awful lot of places it can go wrong. Let's make sure it actually works. So if I change post users to post login, oops, I probably, all right. I'm just gonna check that the wrong ways worked. So if I do Kyler, bad username. If that's Kyler, bad password. All right, so otherwise, I'm in here. So cool, last step, create a token, sign it, send it. So a token is gonna have a payload. So I can set that payload equal to maybe something like user ID is at user.id. I can't do payload equals at user because that user is an object. This is like something that I'm going to need to turn into a string. Like, I don't want to turn the whole object into a string. Just I want to pick and choose which pieces. All right, so I have a payload. Now I need a secret. And then I need to turn that into a jot. So we can do that by just saying gem JWT and then doing a bundle install. Cool. And that's going to give us the jot class. And we can do something like jot.encode. And I want to encode this payload with this secret. And that's my token. So then I need to send that back. Render JSON. Let's see, token. Give that a status too. All right, I wonder if it worked. So if I get them both right, hey, there's my token. And since the tokens are encoded, not hashed, not encrypted, and I can even hop over to jwt.io, paste it in, and see my user ID. Pretty cool. And all that is step 2. Questions about any of that?
I did have a question.
Yeah.
One of the, looking for it now, it's like Rails application, something secret key.
Yeah.
Or something like that. I saw that in one of the videos. I wanted to just kind of get a full understanding what that's really doing. Absolutely.
So I did secret is top secret here. Like, now the problem I run into with this is I eventually want to put this on GitHub, right? Well, it sure doesn't work to make a top secret hash if people know how you did the hash in the first place. So I don't want it to be top secret. I want it to be some kind of like generated thing. Well, Rails actually has that kind of built in for you. You do rails.application.secrets.secret keybase, I think. Yeah, I'm going to go with that. So this will give us like a real secret that was generated by the application itself.
So I had wrote down on my notes Rails application.secret keybase.
Yeah, that's it.
Underscore between secret keybase.
Yeah, there we go.
Yeah.
This is what you get when you don't program for a while. All right, so now I should be able to fire up the server again. Still works.
I have a question. The JWT encode thing.
Yeah.
So that is what you're talking about. Like instead of hashing it, it's encoding it.
Correct. It's encoding it and signing it. So it was only encoded. That's why I was able to paste this into the website and I was able to see exactly what was in it. But it was also signed. That's what the part in blue here is. That is also a hash. And what happens is if you try to tamper with this, if you take your token and go, never mind, user 1 is Kyle, user 2 is Cassie. Now the signatures won't match when you try to send the token back over. Because how the hash works is it takes all of the stuff from this and all the stuff from the header, all the stuff from the payload, and then hashes those. So if any part of those change, the hash ends up being different.
Is the blue part the salt thing? Or
no, there's no salt in this one. The salt would be from like when I created the user. So if I made another user, this, not the server. Users. Okay, so the salt is like the first couple characters of this. I don't know how many it is, but those actually get stored with the hash. So this part is the salt. That part is the actual hash. And so when Kyle comes across, what the library is doing is adding it to this. So it'll be Kyle RDRG0WP. And then it'll check to see if the hash result of that is this.
Okay.
Yeah,
Thank
it's
you.
some like fixed number of characters at the beginning of it. Other questions about these first two parts?
I'm getting back a null token. Any
A null
inklings?
what?
A token, but it's null.
Why don't you screen share? Throw up that controller. All right. So Alan's looking up the user. If the user doesn't come back, no
Is
user
it
with
the
that.
token at render JSON? Is it-
Yeah,
He doesn't need the at symbol, correct?
correct.
Gotcha.
Now try. Cool. Other questions about part two? All right.
Sorry.
Hit me.
I'm getting 404 when I'm trying to do the login.
Excellent. That's the easiest one to troubleshoot. Why don't you go ahead and screen share?
All right.
All right. So we got a 404 uninitialized constant authentication controller. So show me your router. Host login should go to the authentication login. Let me see your controller. Your authentication controller. Authentication. It just says authentication. It's not a controller.
Oh, okay. Let me see.
Did you just make the file?
I
or
might
did-
have just made it a model. You're right.
Yep. There you go.
Okay.
Cool. Fix that. You'll be good to go. Other questions about part two? All right. Let's take a look at the stunning conclusion. Okay, so of course, this is the one that has the steps cut off. So we want to verify a token in Rails. So somebody sends us one of these tokens. How do we know whether or not it's legit? So what we're going to do is we're going to start by just making some resource that we want to protect. So let's say let's do dogs. They're my dogs. You can't see them. So I'll do a resource for this. Resources, dogs, or dogs, only index. All right, so I'm going to route any request to dogs over there. I'm going to Rails G controller dogs. While I'm at it, I'll go ahead and make the model. Sure. I'll make a model for it. Dogs have names.
I'm just real quick, taking a step back. Everything so far up to part two, I'm like, okay, yeah, all good. All of a sudden you're like, let's make dogs. Now I'm lost.
Okay, fair enough. You are probably not the only one. Let me migrate that real quick. So the entire point of doing all of this was that I know who someone is, right? Why do I give a shit who somebody is? Most of the time, that's because I want some users to be able to do some things and other users to be able to do other things. So like, that might be something like, in my user dog like many-to-many thing, maybe it's the case that everybody can see every user. Probably not likely, but whatever. Everybody can see every user. However, you have to be logged in to see dogs. That's like what we're doing right now. Or it might be, if you're logged in, you're allowed to see your own user record, but you're not allowed to see anybody else's. Or you're allowed to see your own dogs, but not anybody else's dogs. So the general idea is that we're trying to protect some resource behind a token, so that unless somebody gives you a token that sort of checks out, you're restricting the kinds of things that they can do. Does that make more sense, Jordan?
Yeah, absolutely.
Other questions about what we're doing? Cool. All right, so I just made a dog model, and I've got this dog controller, and so we should be okay to go on that. And if I do something like dogs is dog.all, and I render JSON, something like this is also mod 2 stuff. We do this all day long. If I throw a couple dogs in the seeds, then I should be able to run these seeds, hit that route, move on with my life. So Rails DB seed. I get all the dogs. Oops. Run the server. Cool, I get my dogs back. But let's say I don't want the dogs to come back unless I'm logged in. That's what we're doing. So first step is, if you didn't even try to send me a token, conversation's over. So I could say something like the authorization header is request.headers at authorization. And I can say, if you didn't send me that, we don't really have a whole lot else to talk about. So I can say render JSON error. And status unauthorized. Cool. There's no magic to this. The same way you do like content type application JSON, well, there's also a standard header called authorization. And that's where you put these tokens when you're trying to make a request from your client. So if that isn't there at all, regardless of whether or not it's accurate, we're done. So all the rest can go inside of that. Let's see if it works. So I'm trying to get these dogs. Do I have an auth header? Sure doesn't look like it. No auth header, bummer. Now, on the other hand, if I put anything in that field, I get them back. No auth header, jack shit. Anything, I get my dogs. And all that's doing is this. Adds that header. Postman has a really cool, slick way to do it. If all these different types of tokens you can send over, bearer token is what we're working with.
I was just gonna ask, what's the bearer added with the A? I didn't see that.
So when you say that you're sending a bearer token, it puts the word bearer and a space in front of whatever other token you put in here. So like if I log in, I get that token. In real life, what I'd do is put that token, put that here. And then when I send it over, Postman is going to add the word bearer in front of that like this. And that's the normal way it's done. Cool. So I do that. And I can get myself some dogs. Questions so far? So I don't actually want the entire header because it comes in with that bearer part of it. I don't need that. I really just need the token. So to get that, I can take the authorization header and just split it on the space and take the second thing that comes back. So I took a string, I turned it into an array, and I want the second thing in the array. That's what that line says. So really, this should be, if you didn't send me a token, I don't have anything to say to you. Cool. Questions about how I got the token out of the header? So authorization header was the string bearer, my cool token, whatever the other parts of it were.
Now, it looked like there are all different types of tokens. So would that be one of those situations where you're like, if, you know, if the split for 0, right, is this, then look at that type of authorization?
You're not going to mix and match like token strategies. So like if you're using bearer tokens, you're using bearer tokens everywhere.
Okay.
But yeah, you could test like for the first part of it. If this word is bearer, all right, next. I need to make sure that like the token is legit. So this is kind of the opposite of this. I took a payload and a secret and made a token out of it. I want to take a token and a secret and get a payload out of it. It just goes the other direction. So secret-wise, same shit. So the payload for this is going to be jwt.decode token secret. And for kind of complicated reasons, the thing that comes back from jot.decode is always an array. And you want the first thing that comes back. That's the payload. Cool. So the what happens if this wasn't a valid token? We actually can't use if statements for this. We have to use error handling because it'll throw an error if the thing can't decode. So you probably did this at least in one lab, but this is what begin and rescue are for. So we have a begin, a rescue, and an end. This is a lot like if and else. Works the same kind of way, but it's for things that throw errors, not like things that return true or false. So if that throws an error, it goes to this rescue clause. Otherwise, it just keeps going. So we could say something like, all right, if that didn't work, then the token wasn't right. Something broke during that process. Okay, so I get this payload. The payload is going to be that same hash that I made. It's just this. Since I have that user ID, though, that means I can look up the user. I'm not doing anything with it here, but I could do something with it. So I could do something like user.find payload user ID. Cool. So, and then all the rest of it kind of works the same way. Let's see if it worked. Oop, didn't like something about my token. Let's try logging in again. Or at a minimum, we know that something in that process threw an error. All right, so I get a token. I go over to my authorization tab. I've got a bearer token. I put that token in. And now I ask for dogs. Oop, still didn't like it. All right, so let's see what it thinks is happening. Nothing in there. I'm going to put so one of these 4 statements through the error. And I'm betting it's this first one. Let's see if it ever gets to that buy bug. Ooh, it did. So now I can take a look at it. What is payload? Hey, and cool. Oh, you know, can anybody see what it is? This is one of the reasons I don't like Ruby. It's really subtle.
Thinking it has something to do with that at user.
Not quite. It's on that line. That's the line that's going to error out.
Find by.
It's not find by because I'm trying to get the ID out. Find works with IDs.
Your user ID is not set to a string. It should be set to a string instead.
Bingo. I looked up user ID, the symbol. It's stored in that hash as a string. Wah, 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 wah. Dumb. Bad language design. There we go. All right, so try running that server.
Buy bug's still in there.
Oh, yes, it is. And there's my dogs. It worked. I'm going to kill that buy bug. All right, so I run the server. I'm sending over my good token. I get my dogs back. If I change that token in any way, if I put an X in front of this, bad token. I have successfully protected a resource with a token. Let's take a look at that code. I looked for the header. I pulled the token out of it. If there was never a token, well, then they weren't even trying. Otherwise, I pulled the secret out. I got the payload out of the token by decoding it. I looked up the user just for funsies. And then I went about my business. If any part of that failed, I said that there was a bad token. Ta-da! ask me some questions about this.
Is there a way to write a utility function so we don't have to repeat this in every resource?
And boom, home run. Yes, there is. Before I show you how to do that, anything else?
This begin rescue stuff or the try catch. That's
Correct.
a lot of like this, like the defensive programming to just make sure users or rapscallions can't break your stuff. So especially important on like the backend server.
Like it's anything that could throw an error, because if they don't give me a token, that's not an error. That's just false. So, or falsy. So I can do an if else for that. If it breaks, you can't if else that. So you have a different, but it works exactly the same, kind of sort of construct, where I'm going to try any of these things. And if any one of those shits the bed, it jumps over here instead of crashing the program. It gives you an opportunity to handle your error and recover from it, presumably.
So it's like a try and accept.
Yeah, this is literally the exact same thing as try catch. Ruby just uses different words for everything.
Okay.
Other questions?
Can we have an off part 2 of part 3 again like tomorrow?
Yeah, and we can talk about the client part of it, although it's really not much. It is the only thing that's different on the client side is when you make your fetch request or whatever, it's got to have that token on it. And when you log in, you keep your token in local storage. It's like 3 lines of code.
Yeah, I definitely like to see this like in action on an actual web page.
Yeah, man. Other questions about this general idea?
Not a question, but can I see your authentication controller? Because mine keeps just saying that my username doesn't work, but it's the same username, so it might just be, I don't know.
Like from part 2, what I really like is when you were doing the JWT decode, and that's when it kind of clicked for me. I was like, oh, because you're encoding it in your authentication, and then you're decoding in your dogs.
Yeah. It's just the same process backwards. This one was payload and secret makes a token. The other one is token and secret makes a payload.
Why is JWT pronounced Jot?
I don't know. They didn't ask me.
I was trying to look it up and it doesn't make, there's no real reason apparently. Just curious.
Yep. Yeah, because I don't know, the people who got to decide that. Oh, here's a Quora. This is the fucking creator of the Elder Scrolls, of course. There we go. Because you can't pronounce Jot and hope to retain any dignity afterward.
That's so dumb. Like you just can't pronounce it. You pronounce it something that doesn't make any fucking sense.
Correct.
Right on.
Jute. Any other questions about protecting resources? So to wet your whistle a little bit, Gerald pointed out like the real next problem we run into is you have more than one thing in an app that you need to protect with like tokens and stuff. Like it might be most of your app. Well, you're going to copy and paste this into every single method? That doesn't feel very programmery. And alas, we do have a way to extract all of this out. And I think Rails does this more cleanly than any other thing I've seen. So we'll talk about that tomorrow. Any last questions before we wrap for today? Survey's coming out.
Thanks, Kyle.
Why are we clapping? Come on, man.
Like,
See,
We can clap.
it takes me a while to get back in the groove.
It was
All
an
right.
off start, so we're gonna have an off ending.
There we go. All right, see you guys soon.